Welcome back, everyone. I don't know about you, but I'm still a little bit buzzing from Chi's keynote. I'll try and calm down now. Anyway, now we've got some more exciting stuff. We've got the first of today's three life lessons from engineering sessions. And if yesterday's were anything to go by, I'm sure we're again in for a real treat, some interesting stuff and some real practical things for you guys to take away. So I have great pleasure in welcoming Maria Sabatini, who's Engineering Manager at DSP Dialog Semiconductor, who are one of our sponsors. So thank you to them, and welcome, Maria.
Thank you. Thank you for the introduction. So yeah, I'm an engineering manager at Dialog Semiconductor. I look after a group that specialises in digital signal processing. So recently, Dialog were acquired by Renesas Electronics, and now they are a Renesas company. Oh. Hello?
Sorry. Oh, yeah, you're back, Maria.
Sorry, really sorry.
We lost you.
Sorry, I'll quickly get back into it. Sorry about this. Okay. Are we back on? Okay, I'll just carry on. My background, so I have 23 years experience in the tech industry, although you might not think so after that experience. I'm a software engineer. My background is in embedded software engineering. I have experience working in both defence and commercial industries. So my first job was working for a company who were making communications equipment for military aircraft, and I was writing software for that system as my first job. From then, I then moved on to a company who were manufacturing mobile phones, and I was writing low-level drivers at that time, specifically audio drivers. And then from there, I moved to Cambridge and got a job working for a hi-fi company. And I was writing or designing menu systems for DVD players. I spent 6 months in China, which was a great experience, loved it. And then from there, I got a job working for a company who were making flash memory, and they were branching out into making media players. So I got great experience working on those, developing my technical skills, and I also spent some time working with third-party suppliers in Central Europe. And then from there, I moved to Dialog. So I've been at the company now for 12 years. So I've worked in lots of different business units at that company. It's semiconductors, so we're sort of delivering in DSP solutions into the chip. And the business unit we work for now are specialising in sort of IoT devices, connectivity and wireless audio. So devices such as wireless earbuds, wireless headphones, hearing aids. We're also involved in developing haptics type solutions, so handheld sort of haptic feedback and IoT devices in terms of sensor processing. So also as part of my job, I work with business units to support them in terms of technical strategies. So not only the things we have to deliver today, but the things we're going to have to deliver, say, 3 to 5 years' time. I'm also involved in reviewing technical specs and technical designs. I'm also a people manager, so we look after 12 people in all, and I'm also involved in planning. So it's important that the business knows when we're planning to deliver solutions to customers. Motivation, so in terms of, why I enjoy being an engineer, so I really like the variety of work that it gives me. So I've really enjoyed working in all the different industries and the different array of products And technology is always something that it never stays still for long. It's always evolving. And it's been a great experience learning and also to make great products that people want to buy. So why did I become an engineer? So when I was growing up at home, I was surrounded by tech. So I grew up in the 80s. So we had a TV with all 4 channels. And we had hi-fi equipment, videos, Walkmans. My brothers and I would, record each other on tape, and we'd make mixtapes for each other and our friends. And then as I got into my teens, I was really into music, and I would spend hours listening to records and reading all the information on the record sleeve. And I was reading the credits and saw there was a position called a sound engineer. And that really caught my imagination, and I started to research to see what was involved in becoming a sound engineer. At school, my favourite subjects were physics and music. And when I was looking to go to university, looking for a course, I wanted to find something that would support my ambitions to be a sound engineer. And Glasgow University were doing a course called Electronics with Music. And it's based on an electronics degree, but has sort of music extensions, so things like music technology, music recording, live recording, editing, and music theory. So as part of that course, in my final year, I worked 6 months in Italy, working for a company who were making a sound synthesis system in Rome. And I was developing some software applications that would work in conjunction with that system. Also, in my final year, I did some voluntary work at Hospital Radio and worked in a recording studio. And that really gave me great experience. Around about the time I was working in the Hospital Radio, we were getting lots of requests for the Verve, The Drugs Don't Work, and Celine Dion's My Heart Will Go On. Now, that is not a joke. That is 100% true. Good experience in the recording studio. Really enjoyed working with all the local bands and doing tape hopping, and learned a lot about how to run, what's involved in running a recording studio. But one of the things that really stood out to me when I was doing this work experience was just how a lot of people were on fixed term contracts. And it didn't sort of occur to me, or it wasn't something that I thought this is going to give me like job security. So job security at that time is really important to me. So I decided to go through the normal recruitment process, and that's when I got the job working at a defence company, and that was really where my career started. So, after 23 years, you can imagine I've had a few challenges, but what I've sort of come to realise is that challenges can sometimes give you opportunities, and certainly gives you lessons to learn. So the first challenge I'd like to present to you today is an issue we had with some algorithmic hardware that we developed. Now, the problem we had was that bugs were being reported on this piece of hardware, and they were reported at a time when we couldn't actually change the hardware anymore. So the only thing you can do in a situation like that is implement software workarounds. And what that means is that you're writing software around the hardware to make it behave in a different way. So we were working with a partner at the time, and they were integrating our chip into a product, and they were reporting a number of issues. So each time we got one of these issues, we had to go through a debugging process. So that would entail them communicating to us what the bug was. And in that communication, they have to provide sort of steps that they carried out in order to replicate the bug. So we would then take that information in-house, and we would try and reproduce the issue on the system that we were using. And then once we've reproduced the bug, we then need to go through an analysis process. And what that involves is just trying to understand what the problem is. Why is this problem happening? Once we've understood the cause, we then need to implement the software workaround. And once that's been implemented, we then need to go through, that needs to go into test. And then once the test is complete and passing, it then goes through a release process. So as you can imagine, we have many of these things that we need to address. and it's long hours, and customers are not necessarily the most patient people. So they want things to be, fixed pretty quickly. And we had a lot of complex problems that we had to fix, and it was quite stressful. And in some situations, what happens is when you put all these, when you have a lot of software workarounds, they start to fight against each other. So we had to go back to square one in some instances, and then re-implement them to make sure that they all work together. So part of my job is to make sure that the team remains productive. So do they have all the information they need? Do they have all the hardware they need? Do they need any help from anyone? Also keeping the team motivated. So as you can imagine, doing long hours, solving complex problems for hours on end, it's not very motivating sometimes. So it was quite important that I kept everyone going and celebrating the progress, no matter how small. Even if we've only made small progress, we're still one step nearer than we were this morning. Transparent communication is really important. So part of my job was also to keep the project leads informed and my own line management informed as to where we are, what the status was, were there any new issues, and really just to remind everybody that these are just problems that we just need to work on. It's a temporary measure. We just have to work our way through these, and there's light at the end of the tunnel, so keep going. So once we had solved all of these issues, we then had to go through a sort of an analysis process. So talk about what went wrong, what were the issues, how can we avoid these types of issues happening again? And when we had this conversation, there were three main areas that really stood out. First one was to have better requirement specifications. So requirement specifications are really important. They tell you what your system has to be able to do. And if you don't know, if it's not detailed enough, or if there are any sort of discrepancies in the specification, how do you know that what you're designing is fit for purpose? Requirement specifications also feed into test plans. So if your test coverage is not covering everything, that then reflects on the requirements that were given to you. In terms of the communication, so a lot of people, well, the project leads were basically saying, well, okay, we were writing test reports, but they didn't want to read 150 pages of it. They just wanted to have something that was a bit more condensed. So having a better way of communicating what the test coverage was. So we then got together, we took this information and we made some actions and put some steps in place. And we worked with the business to go through the execution process. So it took 2 years, but now we have a reusable, scalable test bench. We have much better requirements, and that means more focused and efficient testing. And that allows us to find issues much earlier in the development cycle. And just going through this whole process, putting in the hard work and actually seeing measurable improvements at the end of it, really helped us build trust with our colleagues. So the lessons learned, first of all, ask help when you need it. When we were going through the whole debugging process, I got quite overwhelmed with the number of issues that we had to deal with. So I had to reach out to the project leads to help me kind of prioritize, what are the most important things we need to work on first and what can we do later. Resilience is so important. So if you have enough grit, you can solve any technical problem. And really, these are just problems, and you just have to keep working through them until they get fixed, and not to give up. And probably the most important is to treat failure as a means to learn and to grow. If you went through life and never had any problems, you went through your professional life and never had any issues, then that's great, but you're not going to learn very much. So having these types of things will help you learn and to grow to become a better engineer. So the second challenge, a project that's been cancelled. So, you might think that a project being cancelled is quite detrimental, but it probably happens more often than you might think. And there are good reasons why projects get cancelled. And that could be because there's a change in the market or there's a change in budget, so that you're developing something that the market doesn't want anymore. So it doesn't make sense to carry on developing it. Projects get delayed for all sorts of reasons, and also because projects can become, you're doing some feasibility and it's just not technically feasible. But what was different here was that the product line was discontinued. And in an extreme case, what that might mean is that the team gets disbanded. And I really didn't want that to happen. And I didn't think it was something that was necessary. We had a unique skill set. DSP is not something that many people can do. We had a highly skilled team, and I knew that we could continue to add value to the organization. So as you can imagine in the team, people were upset. There was a mix of emotions. People were sad, surprised. And I had to remind them, that these are situations that you have no control over. So projects that get cancelled is purely a business decision. And the only thing that we can really control is our reaction. So the opportunities, that we were trying to pursue was trying to get into maybe some new projects, interesting projects, new technologies even, working with new groups potentially and new colleagues. And really what we're looking to do is show what we can achieve. So I had to ask myself the following questions, what are our skills and strengths? What are the types of things that motivate us? And what, where in the business can we contribute the most? So, we're highly skilled software engineers. We have signal processing skills, which are quite niche. We have a proven track record in developing complex algorithms and testing those. And we really enjoy innovation and working on new ideas. So I reached out to my network and told them about our situation and the types of things I was looking to get involved in. And their advice was to talk to a section of the business called the Advanced Technologies Group. And what they are is they're a group of people who are working on technologies which are not necessarily, projects that are active and, going to be released in the next year or so. These are a group of people that work on technologies which are, anticipated that the market will need in 3 to 5 years' time. So we spoke to them and they said that they were working on some sensor applications and they were looking for somebody who could perhaps, write an algorithm that could process sensor data for a specific application they wanted to support. So we went off and we did some feasibility and we made a prototype and we showed it to them and they really liked it. And that then started a new project. It went into a product, so we had new customers. And we patented some technology that we actually developed at that time, and it went into a sort of internal competition that the company runs every year, and we won the patent of the year. So that was really nice. So the lessons that I learned from that were to really nurture your sort of working relationships. Working networks are so important. Don't worry about the things you can't control. The only thing you really can control is how you respond. And perspective is really important. So how you think about a situation can really influence your behaviour, and that will influence the outcome. So having a positive attitude from the start means you have a better chance of having a more positive outcome. So advice on entering the engineering profession, what would I say to myself? Well, firstly, the most important thing is to ask questions. Never be afraid to ask a question. It helps your learning process and it lets others around you understand how they can support you the best. So, and in my experience, there's no such thing as a silly question. There's really only silly answers. So stay curious. The next one, accept that you can't know everything. So as an engineer, I put so much pressure on myself that I, having to know everything. If somebody asks me a technical question, I have to have all the answers. And that's just not possible. And I learned that the most when I became a manager. So I look after 12 people and I could never know what all these 12 people know. So I would go into presentations, trying to put all this pressure on myself, being able to answer all the questions. And, really, it's perfectly acceptable to say, that's a really good question. Let me have a look at that and I'll get back to you. It's perfectly acceptable. So the last one, getting out of your comfort zone is important for growth. So being in your comfort zone is sort of nice. You've developed your skills and you're in your sort of fuzzy zone where you're doing really well. And it's only when you start to stretch yourself, you start to learn new skills and develop. So this becomes important, particularly when you're involved in, or you're offered sort of new opportunities. So it could be like a new position or extending your current responsibilities or going into a new job. And if you're kind of worried about, am I going to be ready for the next step? Well, the truth is you're never really going to be ready until you actually go in and do it. And that's what I've learned. And I remember having the opportunity of joining Dialog. I joined as our first DSP engineer, and I hadn't done any DSP for about 10 years. So it was a bit of a daunting prospect. But I decided, I thought it would be better to try something. It's better to regret something you've done than something you haven't. So I went ahead and went for it, and I'm really glad I did, looking back. So how does engineering connect society? So first of all, it connects us in terms of transport and logistics, delivering us, food and medicine and all the things that we need. Telecommunications are also very important. So things like mobile phones and broadband, we all heavily rely on now. I don't think many of us would have been working from home if we didn't have broadband. They also supply us water, gas and electricity, sanitation, all these things that we take for granted. And it also protects us in terms of flood defences, which could become more important now with climate change. And, in terms of medicine as well, bioengineering, developing new antibiotics, developing vaccines and medical equipment such as scanners. And in terms of the global challenges, well, I think we all fully understand the investment that is so important in terms of sustainability and renewable energies to reduce our carbon footprint, particularly in the case of things like solar arrays and wind power is really important. And all these things that we take for granted, all the clean water and access to electricity and sanitation, it's not something that they have all over the world. So engineers should be looking at ways, particularly renewable ways of being able to provide access to clean water, better sanitation and improving crop yield. I read an article where engineers were using solar arrays to use to irrigate crop fields and to improve crop yield in the developing world. And semiconductors. So a lot of the devices that we use all contain semiconductors, and that goes for solar arrays and wind turbines. And the demand for semiconductors is only going to grow. And fabs that make semiconductors have their own carbon footprint. They use billions of gallons of water, and they produce some hazardous waste. And engineers should be, looking at ways of reducing that and really targeting to source 100% of the energy into renewable sources. So that's the end of my presentation. Thank you very much for listening, and I'd be happy to take any questions.
Great, Maria. Thank you so much. So many good nuggets in there, and yeah, some really funny points as well. You did make me laugh. But really great stuff. It's almost like you heard the questions from yesterday, but I'm going to crack on with the questions because there are loads in the chat. So the first one is from Ashnar. Thanks for sharing your experiences, Maria. Amidst the stressful and complex scenarios, your team must have encountered conflicts. How do you tackle such situations? And I think you've been really great in this presentation at putting out some really practical advice on how to behave professionally in certain situations. So this is a great question.
So in terms of handling conflicts, I think, at the time, I think people were just so focused on achieving the common goal that there didn't seem to be much friction at all. But in terms of managing conflicts as a people manager, yeah, you do have to deal with that. And a lot of that is just being completely objective, hearing all sides of the argument, and really just finding sort of the common areas and areas of how conflicts can be resolved. So yeah, really important to keep an open mind and listen to all sides.
Great, thank you. Nula's got a question. Thank you, Maria. She's doing a maths degree. What advice would you give for approaching a career in software engineering? I know there are a few nuggets in there, but...
Interesting, yeah. So in terms of signal processing, a lot of that is mathematics. So things like algorithm development. So algorithms are used in a lot of facets of engineering. So cryptography is very important now. Cybersecurity, audio, sensors. There's a whole host of things that need mathematics.
Yeah, great. And then Nabila has asked a question. Thank you for the wonderful advice, Maria. Yes, I'd second that. How do you find the balance between doing things that you're good at and trying to improve at things that you're not so good at? And what are the things that are outside of your comfort zone now?
Giving presentations, I still struggle with that. So
No, you do
even
not.
this is a little bit of getting out of my comfort zone. Public speaking, yeah. So how do you find the balance between doing something you're good at and then stretching yourself? Sometimes it can just be, say you're a software engineer and you're quite proficient in doing C, then maybe you can move into, say, working on, other types of languages, stretching your soft skills, for example. So say that you're very good at sort of talking to small groups, then you can how do you extend that and talking to bigger groups?
I think as well at work you do often have or you're required to have a development plan, and that's not a bad thing, is it? Having that structured think conversation and then having a plan across a year to kind of do some things that stretch you.
Yeah, I mean, if you have a sort of a long-term goal, so say you want to be working on a certain project or a certain technology, in say like a year or two from now, to start to understand what kind of skills I'm going to need and what are the steps I need to try and meet in order to meet that goal. And you can certainly work with an advisor or your manager to put those steps in place and to develop your skills.
That's great, thank you. There are another couple of questions in there, but as I mentioned before, we're going to get cut off.
Yeah. So
thank you so much, Maria. Really great talk. I can't believe you're not comfortable with giving talks because you were brilliant. Just a reminder to everyone. So thank you, Maria.
Thank you.
A reminder to everyone that we've got a longer break than scheduled. So we don't need to be back for the next live lessons in engineering until 11:35. But we do have great opportunity to network in the lounge. I don't know, Maria, if you're there, because there seem to be quite a few questions. No worries if not, because I know you've got a job that you have to do. But encourage everyone to get in the lounge and network with other attendees and some of the speakers. But thank you so much, Maria. Brilliant talk. Loved it.
Thank you. Very welcome.
Bye, everyone. See you at 11:35, unless you're going to the lounges, which I would encourage.